You are provided, that's question 2, you are provided with solid C. Carry out the following test. Write the observations and inferences in the spaces provided. Place all solid C in a boiling tube. Add about 20 centimeters cube of distilled water and shake until all the solid dissolves. Label the solution as solution C. Use about 2 centimeters cube of solution C in a test tube for each of the following tests. A. Add aqueous sodium hydroxide dropwise until in excess. This is now where the students go wrong. When you are told to add dropwise until in excess, what it means, first, use 2 drops, make the observation, see what will happen, and then afterwards, add the sodium hydroxide in excess and then make another observation, because here you are expected to make 2 observations at once, simultaneously. So this is what was observed. White PPT. So this is the first observation. When you put a drop, a white PPT is formed. Then what happens when the white precipitate, when the sodium hydroxide, what happens to the white precipitate when sodium hydroxide is added in excess? The white precipitate is formed, which now make form for the excess, which dissolve, or which is insoluble, which does not dissolve in excess. In excess sodium hydroxide. So this is the expectation. Whenever you are asked to add sodium hydroxide dropwise and then in excess, then you should first use the 2 drops, make the observation, and then add in excess, make the observation. So a white PPT is formed which is insoluble, which does not dissolve in sodium hydroxide, meaning the white precipitate remains, persists. So if that is the case, then what is present? What is present is that calcium, 2 ions, magnesium, 2 ions, and barium, 2 positive are present. If the white precipitate dissolve to form a colorless solution, then we know the amphoteric ions are there, aluminium, lead, and zinc. But since this one it is insoluble in excess, it means that the calcium ions, magnesium ions, and barium ions are present. Now you can ask me, is it correct for you to write that lead 2 positive, aluminium 3 positive, and zinc 2 positive absent? It is correct, but unacceptable. It is correct, but nowadays they don't accept that. If it is not there, then tell us what is there. That's why I've given you what is there. Now you know, whenever this happens, what is there is calcium, magnesium, and barium. If it happens otherwise, the white precipitate dissolve to form a colorless solution, write this and this and this present. Don't write this and this absent. Write what is there. Thank you. Add 3 drops of aqueous sodium sulfate. We are adding sodium sulfate. So you are seeing the sulfate. Here we expect, because remember all salts of sodium are soluble. So we are going to expect that this one, if it gets into that solution in our test tube and finds lead, 2 ions, it will form a white precipitate. If it finds barium, it will form a white precipitate. If it finds calcium, it will form a white precipitate, the sulfate. We know salts of sulfate which are insoluble, which forms white precipitate. So what was the observation for this one? White precipitate is formed. So if a white precipitate is formed, but from the if you put that lead is present, then you are contradicting yourself, because initially in our previous inference we said lead is not there. So you don't, where will you get it from so that you can put it here? Therefore, you don't add that because it was not there initially in the previous observation. Therefore, here it is only calcium and barium that are present. Calcium 2 ions or barium 2 present. Sorry, barium nitrate. Whenever we are adding barium nitrate, we expect a white precipitate because barium will form barium sulfate, barium carbonate, barium sulfite. These are the three salts or anions that will form a white precipitate with barium. But now, since there is no white precipitate, then it means the sulfate, the sulfite, and the carbonate, they are absent. They are not there. Otherwise, if they were there, barium would form a white precipitate with n of them. Add 3 drops of aqueous lead 2 nitrate. Lead 2 nitrate. Heat the mixture. We have been asked to heat the mixture. Then this is the observation. A white precipitate, white PPT formed. The observation we have made is for adding red to nitrate. After heating, what happened? Did the white precipitate dissolve on heating or it did not? That is the second observation. A white precipitate is formed which dissolve on heating. So that tells you if you are adding this, then it means a chloride was there. A chloride. So that it forms lead chloride. Red chloride is the only salt which forms a white precipitate, and when warmed or heated, it dissolves to form a colorless solution. But is it only chloride? You can also use bromide ions. So bromide ions and the chloride ions will behave in a similar way because actually they are halogens, you can see. So these two will behave like that. So you say this or this is present. And you get your marks, all of them like that. Let us go to the last bit of it. You are provided with an organic compound. Very important. You have been asked, you have been told. You are not going to find out whether it is an organic. This one you have been given straight that it is an organic compound. Solid D. Carry out the following test, record the observations and inferences in the space provided. Describe the appearance of solid D. It was a white crystal, therefore you say white crystalline solid, or you can say that's or white crystals. You can say it is white crystals because the salt was white. Divide solid D into 4 portions. Yes. Place the first portion of solid D on a watch grass and burn it with a Bunsen burner flame. Then what happened? Remember, it is a solid, so the solid melt and burns with a yellow sooty flame. The solid D melts and burns with a yellow sooty flame. Now we want to know whether it is a saturated organic compound or unsaturated. If it burns like this with sooty yellow, then that tells you it is the unsaturated, the double bond, or the triple bond. Present. It is acceptable for you to say unsaturated organic compound present. It is acceptable to say unsaturated organic compound present. It is acceptable. Place the second portion of solid D in a test tube. Add about 3 centimeters cube of aqueous sodium hydroxide. Now you see, here we are using aqueous sodium hydroxide. Basically, we want to test whether this organic compound is basic, is neutral, or is an acid. Because if it is an acid, it's going to produce effervescence. That's why we are using a base. We basically want to test whether it is an acid. Yes. So let me give you the observation. The solid dissolve. Solid D dissolve in sodium hydroxide, then it dissolve in sodium hydroxide, forming a colorless solution. Now remember, a solid is dissolving in sodium hydroxide, which is a base. Then that one definitely tells you that this solid was acidic, right? Yeah, an acid plus a base, it will give you a colorless solution, neutralization reaction. But now we are dealing with organic chem. Here we give the inference of organic acids. It is acceptable for you to write that acidic organic compound present compound. Acidic, it is acceptable. But also, if you don't remember this, you can write that the functional group of alkanoic acids is present. It means that alkanoic acids are present. One of them is present. Number 3, place the third portion of solid D in a test tube. Add about 3 centimeters of distilled water. Heat the mixture and add 3 drops of acidified potassium manganate 7. Acidified potassium manganate 7. Then the observation is that this one is decolorized. So you just say acidified potassium manganate, permanganate, that is, solution is not decolorized. We have reviewed that it did not decolorize. So another person can say the purple acidified potassium permanganate remains purple because it did not change. We know this one is purple. So if it doesn't change, then it means that the double bond, the triple bond, or the alcohol ROH was absent. Yeah, is absent. If this were present, the acidified potassium manganate would be decolorized. It could change from purple to colorless. But now it did not. It didn't do that. Therefore, it means that these 3 are absent. They are absent. Finally, place the fourth portion of solid D in a test tube. Add about 3 centimeters cube of distilled water. Heat the mixture and add all the solid sodium hydrogen carbonate provided. Then effervescence occurs. that now confirms actually that solid was an acid. Effervescence occurs. Carbonate plus an acid, we always expect carbon dioxide to be produced, therefore effervescence will occur. That confirms that the alkanoic acid are present. Okay, H. The alkanoic acid are present. It is acceptable to write that acidic organic compound present.